In this video, we're going to look at the definition of a square as well as its properties. So a square is a parallelogram with 4 congruent sides and 4 right angles. So let's write that down. So again, there are 4 congruent sides and 4 right angles. So in order for us to really understand what a square is, of course, we need to remember what a parallelogram is. And a parallelogram is a quadrilateral, a 4-sided shape with 2 pairs of opposite parallel lines. All right, so once you remember what a parallelogram is, then now we can talk about the square. All right, so here's the thing. You may recall that a shape with 4 congruent sides is a rhombus. Well, is a square a rhombus? Yes. But is a rhombus a square? Sometimes, not necessarily. So a square is a specific type of rhombus. You may also remember that a figure with 4 right angles is a rectangle. So is a square a rectangle? Yes, it definitely is. But is a rectangle a square? Not necessarily. So a square is just a specific type of rectangle. So a square is a specific type of rhombus and it is a specific type of rectangle as well. That means in order for a parallelogram to be a square, it has to be both a rhombus and a rectangle. I hope that makes sense to you, because here we go with our square, what it looks like. We have our pairs of parallel sides, so I'll put that in. That's parallel to that. This is parallel to this. So that makes it definitely a parallelogram. In addition to that, that, and that are congruent to each other, which makes it a rhombus. In addition to that, we have a right angle here, a right angle here, right angle here, and a right angle here. That makes it a rectangle. So when all those 3 things are true, we have a wonderful, beautiful square. All right, so now that we know the definition of a square, what it looks like, now let's talk about some more specific properties. So in order to test for a square, if we know that it is a rectangle, we really only have to make sure that two consecutive sides are congruent to each other. If we know it's a rectangle and we know 2 consecutive sides are congruent to each other, then we will know automatically it's a square. So that's one important theorem that we should know. Another important theorem here is the fact that, well, we just spoke about it. If it's a rectangle and a rhombus, then it is also a square. All right, so let's try a problem in which we're going to look at a shape and identify if it is or is not a square. Okay, so here we have a 4-sided figure, a quadrilateral, and we have to test whether or not it is a square. There are so many ways to do this. I'm going to actually do it in a different way than I did it before, just because I want to mix it up. So if we're testing that this is a square, it would be sufficient to show that it is both a rectangle and a rhombus. So we can look back at the test for squares and for rhombi, for rectangles and rhombi, but I choose to do it in a different way. I want to show, well, because it really, really looks like this is not 90 degrees, and if it's not 90 degrees, then this is not a square. So I want to show that those 2 lines, JK, those 2 line segments, JK and JM, are not perpendicular to each other. So if they're not perpendicular, well, if they are perpendicular, the slopes would be negative reciprocals of each other. You may recall this from a previous lesson. Slopes are, and that's a question, negative reciprocals, question. All right, so I'm going to check that out. So in order to check that out, of course, I have to figure out what the slopes are. So let's do first the slope of JK. And the slope formula is y2 minus y1 over x2 minus x1. So let's say this is x2, y2, and this is x1, y1. So y2 is 4 minus negative 2 over x2 is 0 minus negative 7. All right, so that looks like we're going to get 6 on top and 7 on the bottom. And so now that we have the slope of JK, I'm going to figure out the slope of JM and see if these lines are perpendicular to each other or not. So let's do slope of JM. And we have, since that was y1, x1, y1, I'm going to keep it as x1, y1 and call this x2, y2. That's my new line. I'm trying to figure out the slope of that line now. All right, so y2 is negative 4 minus y1 is negative 2 over x2, which is 2, minus x1, which is negative 7. And so at the top, we get negative 4 plus 2, which is a negative 2 over 9. So our slopes are certainly not negative reciprocals of each other, because the negative reciprocal of this guy right here is negative 7 over 6, which is not this. No, no, no. Which means that these two lines here are not perpendicular to each other, and we have to go no further. This is definitely not a square, because one of the conditions to being a square is that it has 4 right angles, and we tested one of the angles, not right. We don't have to go any further. Okay, that's it.